Welcome to Proving Trig Identities Day 1. So we're going to start with the following example. If you graph the expression sine 2x over 1 plus cosine of 2x, you get the following graph. So make a conjecture about another expression that is equivalent to this. So if you take a close look at this graph, it appears to look like tan of x. So we're going to try to prove that this expression is equal to tan of x. So let's pick a side and prove the following identity. Let's say we choose the left side. So if I'm going to start with the left side, I'm going to use my double angle formulas. So I'm going to use the fact that sine of 2x is equal to 2 sine x cos x, and I'm going to use cosine 2x, and you can pick any of them. So I'm going to pick, let's say, the first one, cos squared x minus sine squared x. And let's see what happens. Remember, our goal is to get tan of x. Let's rearrange the denominator. Next, we'll deal with the 1 minus sine squared. So I'm going to use the following identity. So I get 2 sine x cos x, and I'm going to get cos squared x plus cos squared x. So that gives me 2 sine x cos x over 2 cosine squared x. I can cancel one of the cosines from the top and bottom and the 2 from top and bottom. So this is equal to sine x over cos x. And the final identity I can use is that sine x over cos x is equal to tan x. And we're done. We've proven that the left side is equal to the right side. Next up is the cofunction identity. And the cofunction identity states that cosine of pi over 2 minus x is equivalent to sine of x. Or sine of pi minus 2 over x is equal to cosine of x. So we're going to prove this cofunction identity. So let's pick a side. So let's start with the left side. So I have cosine of pi over 2 minus x. So I'm going to use my compound angle identity for cosine A minus B. So using that identity, I end up with cosine of pi over 2 cosine of x plus sine of pi over 2 and sine of x. Next, we're going to evaluate cosine and sine of pi over 2. So let's look at our graphs for cosine and our graph for sine. And remember, pi over 2 is right here for cosine, and pi over 2 is right here for sine. So I get 0 times cosine of x plus 1 times sine of x, and therefore I get sine x. And we've just proven that the left side is equal to the right side. And again, we could approach either side. I'm going to do the right side on this one. Let's start with the right side. So I get 1 plus tan x tan y over 1 minus tan x tan y. Again, there are multiple ways to approach this. So I'm going to use the following identity, that tan of theta is equal to sine of theta over cos of theta. And let's see what happens. Next, I'm going to find a common denominator for both the numerator and the denominator for this expression. And the common denominator is going to be cosine x cosine y. Since we have a fraction over a fraction, I'm going to flip and multiply. Notice we have factors in the numerator and denominator that we can cancel. And I'm left with and now we have our compound angle identities. So we're going to use our compound angle identities. And if you look at the list, the numerator here is the cosine of x minus y, and the denominator is the cosine of x plus y. And now our right side looks like our left side. And our final example. I want to prove that tan 2x minus 2 tan 2x times sine squared equals sine 2x. There's a long way and a short way to deal with this. I'm going to try to show you the shortest way. I would start with the left side. And I notice there's a common factor of tan 2x. So let's remove this common factor. So we have tan of 2x. And what we have left over is 1 minus 2 sine squared x. So let's use some identities. So I'm going to use one of the quotient identities. And I'm going to use one of our double angle identities. So what I get is, notice I can now cancel the cosine 2x in the numerator with the one in the denominator. And I'm left with the sine of 2x. So therefore, our left side is equal to our right side. Again, you could approach this in many different ways. I think this would be the quickest, but you can try some other ways and let me know. So here are some tips. Again, simplify the more complicated side until it's identical to the other side, or manipulate both sides to get the same expression. Notice for all these I just stuck to one side. Rewrite expressions using any of the identities we have proven in class. Again, there are methods like using a common denominator we factored in the last expression, and if all this fails, then start over and try again. Again, here are some questions to try from your book. Here's a good thinking question. Solve this trig equation on the interval 0 to 2 pi, and I've left the answers there for you to check your work.